Alright, this quick video is on working with function notation. And it's not just evaluating function notation, which we will do here, we'll review that, but it's having a number out in front of a function notation, or having something being added or subtracted to the end. What does that do, and how does that change our answers to the function notation? So we're going to look at that. We have one function here, it's f of x equals 3x plus 7. Alright? We've got several examples to look at. The first two here are both just evaluating. First one is f of 3. So if you remember, to do that, any place we see an x, we just substitute a 3, and then we evaluate the answer. We get an answer to the problem. Well, 3 times 3 is 9, and 9 plus 7 is 16. So there's the answer. That's what f of 3 equals, 16. You can do the same thing for negative 5, f of negative 5. Well, every place we see an x, we're going to substitute a negative 5, and then simplify and evaluate and get an actual answer to the problem. Well, 3 times negative 5 is negative 15, plus 7 is going to be negative 8. So there's our answer to that one. That's what f of negative 5 is evaluated. Okay? Now our next example is a little different. Notice there is an x still in the function notation. It's f of x. But at the end, we have plus 5. So we're going to do something a little different here. We're going to substitute out the f of x for what it actually equals. Well, f of x is 3x plus 7. So it becomes all of this, 3x plus 7, and then plus 5 out on the end. And we would do this, the order of operations, and simplify our expression here. Well, there's nothing to distribute, nothing to multiply, but we can combine the 7 and the 5. So our answer ends up being 3x plus 12, because 7 plus 5 is 12. And that's our new answer. Alright, so it's a little different. We're completely swapping out the f of x for what the function actually is. We're not necessarily evaluating it anymore. We're not substituting a number in for x. We're completely substituting out the whole f of x for what it equals. Let's look at this next one. Same idea. F of x minus 2. So every place we see an f of x, we're going to completely swap out the whole function. Well, f of x is really 3x plus 7. And then we have minus 2 at the end of that. And then we'll do order of operations to simplify this. Can't multiply, nothing to divide, anything like that. No powers. So all we're going to do is combine the 7 and the negative 2. We end up getting 3x plus 5. Next one, similar idea, but a different setup. We have a 5 out in front of the f of x. Still going to swap out the f of x, substitute it out. And now this becomes a problem where we could distribute. We're going to distribute this 5 through to both of these. Well, 5 times 3x is 15x, and 5 times 7 is 35. And that's as far as we can simplify this, so we're done. The next problem here, I've written it. It looks like it could give you a similar answer to the one we just did, 5 times f of x, but the 5x is inside. The 5 is inside the parentheses now. So this one actually goes back to the first two, where we're evaluating it for a specific number, because the 5 is inside there. The difference is we have a variable with it also. So we're going to have a variable in our answer. But to do this one, every place we see an x, or we saw an x, we're going to swap out and put a 5x instead. So now it's 3 times 5x plus 7. If you notice, this isn't the distributive property anymore. The 5 isn't going to both of them. It's only being put with the 3 because that's the only spot the x was with. So notice that you're going to get two different answers here based on where the 5 is. We also had our third example up here where the 5 was at the end, added to it. Another completely different answer. So depending on where we put the number and what's happening to the function, we could get some completely different answers. When we simplify this, it becomes 15x plus 7. So again, a different answer from the one we had before because the 5 is in a different place. Two more examples here. The next one is f of negative 1 plus 3. Well, if we look at the first part, f of negative 1, we're going to evaluate that. There's just a number inside there. So we're going to go ahead and figure out what f of negative 1 is. Every place we see an x, we're going to plug in a negative 1. So 3 times negative 1 is negative 3 plus 7 ends up being 4. Now that's not the answer to the problem, because we'll swap that f of negative 1 out now with a 4, and then we're going to add 3 to it. So the answer to the whole problem is 7, because 4, what the f of negative 1 equaled, plus 3 is 7. I'm going to do one more here. This has got 2 different operations going on with it. Notice there's nothing to evaluate the f of x at. So we're not going to actually get a single number answer. We're going to swap out the whole function and replace f of x with what it equals. So we have negative 2 times 3x plus 7, because that's what f of x was, and then minus 10 at the end. Now here we have to do our operations in the correct order. Remember PEMDAS, parentheses, exponents, multiply, divide, add, subtract. You need to do the order of operations correctly. So we're going to look in the parentheses first. Nothing we can simplify in there. 3x plus 7 is already simplified. So the next thing we're going to do is distribute. We're going to multiply. Distribute the negative 2 through. Well, negative 2 times 3x is negative 6x. Negative 2 times 7 is minus 14. And then we have that negative 10 at the end. Now we're going to combine what we can. We have negative 14 and negative 10 that'll combine. So you end up getting negative 6x minus 24, because negative 14 minus 10 ends up being negative 24. So here's our answer to the problem. All right? Now the goal of this video was to make sure you understood what you were actually doing with function notation. So look back at these examples. If there's a single number or a number and a variable inside the parentheses, you need to evaluate the function at that number, or that number and variable at that expression, and get a single answer. If it's just the name of the function, f of x or g of x, and something's happening out in front, or you're adding and subtracting something to the end, then you're going to swap out the whole function for what it equals and get an expression as your answer. All right, so really pay attention to what you're doing, because little subtleties, for example, our 5s here in our 3rd, 5th, and 6th examples, you notice they all have a 5 in them. Different things are happening. We got 3 completely different answers. So pay attention to what you're doing. If you have any questions, bring them to class next time, or go back and rewatch the video and see if that clears anything up.